We now have the tools we need to talk about a very fascinating aspect of rotational motion, and that is stability. If I take this ring and I try to balance it on the table, it always falls over. However, if I spin it, we can see that it stays on its edge. Now, to understand why this occurs, we've talked about angular position, angular velocity, angular acceleration. We've talked about rotational moment and torque and rotational kinetic energy. And none of those would lead you to guess that spinning would make it so stable that the ring will sit on its edge. To understand it, we really have to think about momentum. So remember when we talked about linear translational momentum, we kind of went back and found a new way to think about Newton's laws. Newton's first law, an object in motion tends to remain in motion. That really meant that if an object is moving, it has a momentum, and if nothing acts on the object, it maintains that state of momentum. And Newton's second law said if you have an external force, that can change the state of momentum, delta P over delta T. So here we have a constant momentum, but if I apply a force, I can change it. Well, that's really what's happening with the ring. The spinning ring has angular momentum, and angular momentum is also conserved. So if nothing acts on it, it wants to maintain that state of angular momentum. So really, the motion continues for the same reason the motion of the ball continues.